everyone, welcome to E-Content Development Center, Majlis Arts and Science College, Puramannur. Myself, Jinsi, Assistant Professor in Department of Physics. Now we are going to discuss about radioactivity. After this section, you can be able to understand radioactivity and different types of radioactivity. Radioactivity, first discovered by Henry Becquerel in 1876. He observed that pitch-blende anode of uranium emits certain radiation and can affect photographic plate. These radiations were termed as Becquerel rays. Later on by Marie Curie and Pierre Curie discovered that polonium and radium are the strong source of Becquerel rays. The studies of these radiations revealed that they consist of helium nuclei, electrons and high energy photons and are produced due to disintegration of the nuclei. The definition of radioactivity. The decay of atomic nuclei with the emission of helium nucleus, electrons and high energy photons is called radioactivity. Then the helium nuclei are called alpha particle, the electrons are called beta particle and the high energy photons are called gamma particle. Then there are natural radioactivity and artificial radioactivity. Natural radioactivity. The radioactivity exhibited by naturally occurring elements is called natural radioactivity and it takes place spontaneously without any external cause and also it is exhibited by the nuclei with Z greater than 82. The example for natural radioactive elements are radium, actinium, polonium, etc. Then artificial radioactivity. Certain nuclei which are stable can be converted into unstable isotopes by bombarding them with fast moving particles. The unstable isotopes so produced undergo radioactive decay, thus the phenomenon of radioactive decay by artificial means is called artificial radioactivity. Then cause of radioactivity. The instability of the nucleus is the main cause of radioactivity. The nuclei with a higher atomic number have low binding energy per nucleon and also due to the presence of large number of protons in the nuclei, then there exists a high Coulomb repulsion. Owing to these reasons, nuclei with Z greater than 82 spontaneously emit radiations to achieve stability. Then nature of alpha, beta and gamma rays. To see the nature of these radiations, a radioactive element is placed in a cavity drilled in a lead block and the radiations coming from the radioactive substance are subjected to an electric field provided by the electric plates. Then we can see that the alpha ray deflected slightly towards the negative plate and the beta ray deflected towards the positive plate and gamma ray remains undeflected. So we can conclude that the alpha ray are the stream of positive particles and the beta ray are the stream of negative particles and the gamma ray are the stream of uncharged particles. Then the properties of alpha, beta and gamma rays. The first property is identity. The identity of alpha particle is helium nuclei and the identity of beta particle is electron or positron and the identity of gamma particle is electromagnetic radiation or high energy photons. The next property is charge. The charge of alpha particle is plus 2e and the charge of beta particle is minus e or plus e and the charge of gamma particle is neutral. The next property is rest mass. The rest mass of alpha particle is 4 times of the mass of proton and the rest mass of beta particle is equal to that of an electron and rest mass of gamma particle is 0. The next property is speed. The speed of alpha particle is less than c and the speed of beta particle is less than c and the speed of gamma particle is equal to c. Then the penetration power. The penetration power of alpha particle is very small and the penetrating power of beta particle is up to 10 mm of matter and the penetration power of gamma particle is very large. The next property is ionizing power. Alpha particle can produce intense ionization and beta particle can produce 1/100th of alpha rays ionization and gamma particle can produce 1/100th of beta rays ionization. The next property is fluorescence. Alpha particle can produce fluorescence on striking certain substance and beta particle can produce fluorescence and gamma particle can produce less fluorescence. This is the pictorial representation for penetrating power of alpha, beta and gamma ray. An alpha ray can stop by a paper, and beta ray can stop by a 0.5 cm of lead, and gamma ray can stop by a 10 cm of lead block. The next one is types of decay. There are 5 types of radioactive decay process: alpha decay, beta decay, gamma decay, positron emission and electron capture. Then we can go through the details of decay process. The first one is alpha decay. During this process, the mass number of the nuclei decreases by 4 and atomic number is decreased by 2. That is, XAZ is changed to YA-4, Z-2 plus an alpha particle. Next one is beta decay. During this process, the mass number of the nuclei does not change, but the atomic number increases by 1. That is, XAZ is changed to YAZ plus 1 plus an electron. The next one is gamma decay. During this process, neither the mass number nor the atomic number of the nuclei changes. The emission of alpha and beta particle generally leaves the resulting nuclei in an excited state. Then return to the ground state is accompanied by the emission of gamma rays. The next one is positron emission. Is the process of emission of positron. During this process, the mass number remains unchanged, but the atomic number decreases by 1. That is, XAZ changed to YAZ-1 plus an positron. Then electron capture. When the excited nuclei is proton rich, it often returns to a stable nuclei by capturing an orbital electron. This process is called electron capture or K capture. That is, XAZ in excited state plus an electron gives YAZ-1. The vacancy in K shell is filled by transition of electrons from higher orbits with subsequent emission of characteristics X-ray. Here I am concluding my session. Hope you all understood my session, and thank you so much for watching.